Hello students, welcome back to computer organization classes. So the next topic from second module is handling multiple devices. So earlier we were talking about the interrupt, right? Interrupt is a hardware signal. It is generated by peripheral. Whenever the interrupt is the signal is asserted, necessary service should be provided by the processor, right? So how to handle the multiple devices? Yesterday we have seen some issues, right? What to do and what not to do, multiple request arises and all. So we'll be discussing in detail about them. So while handling multiple devices, the issues concerned are, you see, first one, how can the processor recognize the device requesting an interrupt? Obviously, since multiple devices are connected, device identity, using device identity or address, right, it will, a processor will identify which device is raising the interrupt. How can the processor obtain the starting address of the appropriate interrupt service routine? Because interrupt service routine is a subroutine, right, which will be stored in separate part of the memory. Whenever the interrupt is raised, control should change the path from main function to corresponding ISR. How this switching takes place, the question comes, right? Should a device be allowed to interrupt the processor while another interrupt is being served? So this is also one of the important factor. Whenever the processor is serving a device, say it is handling one ISR routine, interrupt service routine, then simultaneously is it possible for the another device to trigger the processor or to raise the interrupt for the processor? And finally, how should two or more simultaneous interrupt requests should be handled? That can be done with the help of having parallel line or dedicated line, connection line, interrupt request and interrupt acknowledgement line. We'll see them later. So these are all the issues. Please note down these things. Okay. Uh, while handling a multiple devices, this is obvious, this is the general scenario with respect to all the computer, because there are multiple devices you can find, like two different types of key input, like keyboard, mouse and all, and output devices also available, like speaker, monitor, right, or printer, whatever. Next is about the polling process. So polling, in here information needed to be to determine whether the device is requesting interrupt is available in status register. Here the device which is requesting for interrupt, it should register itself with the status register, the corresponding flag bit. Okay. Uh, so the condition codes of the flag bit are mentioned, some of the condition codes what we are using for our discussion. So DIRQ, the notation which stands for interrupt request for display, interrupt request for display, where D stands for display, IRQ for interrupt request, KIRQ is the interrupt request for keyboard. And enable and disable interrupt, as you are aware of, interrupt can be enabled as well as they can be disabled, right, as per our previous discussion. So DEN, which stands for interrupt, KEN keyboard enable, DEN for display enable. Then status flags, this we have considered already, S in and S out bits. Okay, input and output status register bits. S for status, input status, in status register, and out status register flag bit. So for input device, sin status flag is used. So if sin is 1, then it indicates the character is entered by the keyboard. Some action to be taken. Just recall what we have discussed earlier. Whenever sin is set to 1, so what happens? Sin is set to 1. It indicates the processor. Processor will keep on checking the flag bit. This status register flag bit, sin bit. So it will, what it will? It will um, identify some data is entered by the user in buffer, and it is stored in the keyboard buffer register data in. So data will be transferred from data into processor register, right? So sin once the data is transferred, sin will reset to 0. So IRQ is 1 when a device, which indicates when a device raises an interrupt request. Any, it can be KIRQ or DIRQ. If KIRQ is 1, which indicates that keyboard is raising the keyboard has raised the interrupt. interrupt request. If DIRQ is 1, which indicates display has raised the interrupt request. You can see the registers in keyboard and display interface. One of the important topic, registers in keyboard and display interface. So data in register, input register, data out register. So for input and output there. Apart from them, those buffer registers, it will be having status and control register. So 8-bit registers there. Right from LSB to MSB, bits are marked 0 to 7. Especially the flag bits, the status and control 8-bit registers are used, marked here, and status register bits are, say, in status register S in, out status register S out, then display interrupt request and keyboard interrupt request. Apart from them, control register is having the enable bits. We can use it for enabling or disabling of the interrupt. Next we have the vector interrupts. So a device requesting an interrupt identifies itself by sending a special code to the processor over bus. So here the processor starts executing the interrupt service routine. So the device which is requesting an interrupt identifies itself by sending a special code to the processor. Its identity, okay, will be sent to the processor first, followed by processor starts executing the ISR, corresponding ISR. Special code indicates the starting address. Obviously, the special code what is generated by the device, okay, the device will identify itself and sends a special code, right, while raising an interrupt. So this special code itself contains the starting address of the interrupt service routine. Since there are various interrupt service routines available, right, processor need to identify which interrupt service routines, like a subroutine, it is to be executed. So this is different for different devices. This ISR is different for different devices. So the code, special code which involves the starting address of ISR, so processor will come to know which ISR routine to be, interrupt service routine to be executed, right? The normally the special code which is sent by the device is of 4 to 8 bits. Its length is, okay. The starting address to ISR is called as interrupt vector. The starting address to interrupt service routine, which is called as interrupt vector. So that is what vectored interrupt is. Okay. Now the topic is about vector interrupt, isn't it? The vector is nothing but the starting address for starting address of interrupt service routine. Starting address of interrupt service routine, which is called as interrupt vector. Okay. Okay. So processor will load the interrupt vector into program counter, because interrupt vector which stores the starting address, isn't it, of ISR, it is to be now whenever the interrupt is called, corresponding interrupt service routine should be executed. So starting address of the interrupt service routine should be loaded onto the program counter, and it executes the appropriate interrupt service routine. That's it. It is about the interrupt vectored interrupt. Okay. Next is controlling the device request. So device request can be controlled with the help of enable bit KEN and DEN. So keyboard interrupt enable and display interrupt enable. You can make it as 0. If you make it as 0, then device will not be able to raise the interrupts. Please remember this enable bits. If you make it as 0 its value, because it's a binary information, it can store either 1 or 0. All the bits you can store single value, either 0 or 1, right? Then KEN and DEN, keyboard interrupt enable, KEN stands for, DEN stands for the display interrupt enable, KIRQ or DIRQ, which stands for keyboard or display unit requesting an interrupt. So keyboard interrupt request and display interrupt request. KIRQ stands for keyboard interrupt request and DIRQ for display interrupt request. So that is about the enable bits. So next is about the interrupt nesting. In case of interrupt nesting, multiple priority scheme is implemented by using separate INTR and INTA. As I told you earlier, so in the previous configuration, we could able to see only a single line INTR, that is common interrupt request line and common interrupt acknowledgement line. But here in this scheme, in interrupt nesting, one-to-one connection. So one-to-one in the sense, each device will be having a dedicated connection to the processor, and uh, that is nothing but dedicated interrupt request line as well as a dedicated interrupt acknowledgement line, which you will be able to see. So processor can set the priority value for each and every device. So it can handle the device based on the priority. So privileged instruction comes. Okay. Here is the diagram. You will come to know. So what exactly it is. Earlier, the diagram was different. What was the diagram? So diagram each it was containing a single INTR bar line and single INTA line, isn't it? But now INTR1, INTR2, INTR so on, INTR-P. Similarly, acknowledgement also, right? The priority arbitration circuit of the processor, which will analyze the priority, which will set the priority value for the device. So based on the priority value, interrupt in case of simultaneous request, interrupt will be handled. Interrupt request will be handled by the processor. Very simple topic. So that is what handling of simultaneous request. So handling of time simultaneous request. So what it does is it will evaluate the devices based on the priority. Okay, and one more configuration we have for this is daisy chain configuration. This daisy chain configuration should be implemented along with the priority group. See here, so arrangement of priority group. Daisy chain is nothing but the previous configuration. It is called as daisy chain, where single INTA and common INTR bar you can find, right, for all the devices. So that is implemented now. Multiple devices are grouped. Now devices are grouped into different categories. So all the devices belongs to same category will be under common group, right? So next, you can find the multiple groups here, where each group is nothing but a set of devices. See, group 1, that is row 1, you just observe, there is a daisy chain which is implemented here. So device 1, device 2, device 3 and so on of group 1 will be having a common interrupt request line and common interrupt acknowledgement line. Similarly, the next group devices, say device 1, 2, 3, 4 and so on of second group, that will be again having a common interrupt request line and common interrupt acknowledgement line. The meaning is any one device from the group can be uh, served, right, and parallelly the device from the other group also can be served. This is what arrangement of priority groups. Next is about exception. Yeah, that is all about the interrupt. Okay, hardware signal. So another very important topic from this module, interrupt. What is an interrupt? Okay, how interrupt requests will be handled. So what is the scenario? What are the scenario? Yesterday we have seen that when first device will raise the interrupt, then what are the changes happens, right? So that you need to study. Then the ways of handling the interrupt, just now what we have discussed: vectored interrupt, then handling of simultaneous request, priority groups. Okay, so this comes under handling of multiple devices. That is all about interrupt. Next is the exception. Okay, an interrupt is an event that causes the execution of one program to be suspended and another program to begin, as we have discussed so far. So causing a generation of the interrupt is nothing but what? It is suspending the execution of one program and starting the execution of the other, right? We are starting the ISR, we are terminating the main function, we are starting the ISR. So next is the exception, which refers to any event that causes an interruption. Okay, exception refers to any event that causes the interruption, which is generally called as exception. Normally these exceptions can also be caused by software, whereas interrupts are caused by the hardware devices. Exceptions are kind of mostly it is termed as software interrupt. Okay, so basically it refers to the uh, execution of the program. So it is called as, hence it is called as software interrupt. So recovery from error is one category of exception. So these are the techniques to ensure that all the hardware components are operating properly. So error detection mechanism is done with the error detection with respect to memory, error detection with respect to memory and all. So that is done by the processor. So if there are any errors associated with the memory, then memory will rise a signal, I mean it will rise an exception, okay, just to indicate there is an error here. As you can see here in the example, ECC, which includes ECC stands for error checking code. Every computer, most of the computers will include the mechanism ECC, error checking code. Next is about debugging. So debugger is used to find the errors in the program, and it uses exceptions to provide a trace file as well as breakpoint. Trace file and breakpoint. So trace is nothing but when a processor is operating in trace mode, the exception occurs after execution of every instruction. So it will show you the path of the control. That's it. Trace is nothing but it will show you, you know about tracing the program, right? What do you mean by tracing? Tracing in the sense following the path of the control. That's it. So it stops, actually trace which stops the stops at every line after execution to show what is the result. And breakpoint here is the program being debugged is interrupted only at specific point selected by the user. You can insert the breakpoint manually. You can insert the breakpoint manually to stop the execution of the program. That is what called as breakpoint. Once the control reaches that breakpoint, it will stop, and that is as per the user convenience. Okay, it will stop the execution at that moment. So these are all kind of sending a signal to the processor, right? Reaching to the breakpoint or executing a trace file and all. Every line will be like, say, it will be a pause for the control, right? So this comes under the these are all comes under the exception software signals. Next is about the privilege exception. So to protect operating system from being corrupted by the user program, privilege instructions are executed only while processor is in supervisory mode. This you will study under Unix environment. Okay, there is a supervisory mode and the user mode. There are two modes available: supervisor mode and user mode. So to protect the operating system from being corrupted by the user program, privileged instructions are executed only while processor is in supervisory mode. Please remember this. So, so an attempt to execute the privileged instruction that will produce the exception. That's it. That will produce a signal which is called as privileged exception. So that is all about the exception. Another small topic. Only three types, mainly about the three types of exceptions you can find. One is recovery from error, debugging, and privileged exception. Okay, and that's it for this session. Let us continue our discussion, that is DMA concept, direct memory access concept, in the next session. Please note down all these points. If you have any doubt, please ask. Thanks for watching. See you in my next video.